new comes, he will like, okay, what is the like new object? Is it circular? Okay, the is circular, that means it is going to be orange, right? So that kind of rule-based thing is going to be developed in his mind, and that same rule-based thing we are going to develop in the algorithm. Okay, so here what is important, like we should have some kind of data, and data will have some kind of features of the some things which we want to develop in the prediction thing. So that is the one of the thing in the machine learning. Okay, and one more thing is that now in current days, along with machine learning, there is one more field is I think that is also included in your syllabus, that is called as a deep learning. Is also picking very good in a good space. So what is difference? I can say it is not a difference. Deep learning is only the machine learning, but what is more? What is the terminology deep learning? Anyone knows? Deep learning is a machine learning only, but what is exactly it is? Yeah. So deep learning basically is a rocket with the data as a fuel. So what does it mean? That when you have very complex data, okay, and you have very multiple features inside the data, you can use an artificial neural network, which is one of the algorithm which comes under the machine learning, and you can predict the things. So here we can develop a lot of layers, which is actually the similar to our neurons, which are in a human body. So on that basis, we are trying to generate some kind of emphasis or results or the models which will going to be for used for the prediction. So that is what is deep learning, right? So now I think I explained this slide earlier. So what are the different types of the machine learning? So as slide says, there are three types. One is the supervised, unsupervised, and third one is a reinforcement model. So anyone can tell me what is the basically difference between all these three models? Yes, anyone please?
I request students to unmute yourself and you can interact with the sir.
Yeah.
Yeah, this will always help you to increase your understanding level and the session will become more.
Don't worry, it is not exam, so
please unmute yourself and you can start.
Sir, in supervised learning, we use label data and we know the output of the given data, and hence we train the machine on the input and output basis.
Okay, as you say that supervised learning, we have input data and we have the output data, right?
Yes, sir.
And in unsupervised, what we have? Let us say that, I will take one of the example. So here, let us say that here in the one of the class, I have a data of the students, and I have one information that every student, I have information like what is the height of the student, and along with that I have the let us say that certain weight I know. So I recorded that particular information from the students. Let us say that I have 171 centimeter height and I have the 71 kg as a weight. Okay. Similarly 169, there will be like let us say 70. Likewise, I have this kind of information. Okay, and for some of the data and some of the new students comes into your class for which I don't know the actually the weight. I only know the height. Okay, and his height, let us say that it is around 150 centimeter. Okay, And based on that, I want to determine what will be the weight of that particular student. So what I will do, that I will create one of the model. Okay, so here on this scale, there will be the height, here will be the weight, and I can have certain data which is like I'm going to make like this one, and later I will make one of the model which is going to be minimize the error for this particular thing, right? And for the new student, which I actually have the information that it is having the 150 centimeter as the height, so which may become somewhere here, okay, which is going to be somewhere here, and which is going to be like here. So this will be the weight of the student for 150 centimeter height, right? So here what information we have, for everything we know this height as the input, okay, and this weight as the output. This information we have, right? So this is called as a supervised learning. Supervised learning basically means that where we actually, it is kind of classroom teaching, where actually a teacher teaches the student what is right, what is wrong, right? So that is actually the supervised learning. And here basically inputs in data science field or machine learning fields is called as a features, okay, called as a features. Maybe like maybe in this case there is only the height, maybe another feature will be there, right? Maybe another feature will be there like that one also we can incorporate, and based on that we can comment the weight of the student. So this is one of the example for the supervised learning. Now what will be the unsupervised? What will be the unsupervised? Now in this case, in the unsupervised, I have only information of the height. Okay, I have the information 171, 169, like 150. This only information I have. I don't have the information about the weight of the student. Okay, so I don't have this particular information. So this, in this case, what we do? Can we predict the weight of the student? Can we predict the weight of the student in that case? Yes, anyone? Very simple question, like if let us say that in earlier example which I told that I have information of the student's height and weight, and based on that I can comment the weight for the unknown weights, right? And in the second example I only have the information for the height of the student. Then can I predict the weight of some of the unknown student which is enter newly in the classes? येईल का प्रेडिक्ट करता आपल्याला? सॉरी, hello? Of course not, because we don't have any information of weight, so we cannot comment on the weight. मग काय करायचं त्या डेटाचं? What we do with the data then?
Identified some patterns.
Right, we have to identify the patterns, right? So what we can do, that we can make some of the clusters, right? We can make the clusters. So hope you are learning these clustering techniques. So there are different clustering techniques like the K-means clustering, hierarchical clustering, DB-scan clustering. These techniques you are going to learn, and you are going to identify pattern. Maybe what you can do, like you can find out the group of students which can have the heights maybe greater than 170. Okay, so all these people will fall into this one of the cluster. One of the group may be having the between the 160 and 169 height, and one of the group will be have the maybe between this kind of thing. So what you can do that this particular thing you can understand, observe in the data, and in the future you can check how the student performance related with the height of the student, right? So that thing you can analyze in the future. But the importance of the unsupervised learning is that you don't have any information of the output of the things you or the dependent variable you want to predict. Okay, so that's why we have to identify pattern. So here one of the example is given like this one. So here I have certain things, certain input data, but I don't know whether this is apple, whether this is like something like this one, or this is one of the flower or something like that. I don't know. So what I'll do, like, okay, this is having the red color, this will have the yellow color, this will have the two colors. So accordingly, I will make the patterns. Okay, so according to these three patterns we can make. And if something new comes, let us say that something which is quite similar to this one, but having the some different shape, like something like this one, but having the yellow color. So it may fall into this category. Okay, or otherwise, if you want to increase the more data, then you have to again train the model, and then you can create your own more category. So this is what the unsupervised learning. Okay, so this is the difference between the supervised and unsupervised, which is the major one. In the supervised, what we do, we generally predict the things, right? We can forecast the thing, but with the unsupervised, it is not possible. So generally, unsupervised is used whenever you want to do exploratory data analysis thing. Okay, so EDA thing is done only because with the unsupervised machine learning technique, right? And last one is a reinforcement learning. So what is reinforcement? What is reinforcement? Let us say that one of you went or miss on some of the island. Okay, some of the island you have went and you just miss on that one. Now you don't have any contact with outside world, right? Then what you are supposed to do now? What is like you have to survive on that island? What you are going to do? You don't have any outside connection. So what you are going to do, like you are trying by your own, right? You are trying by your own to learn new things. Maybe like some of the fruits which are not available on this one, you can eat and check it. If it is, let us say that it is healthier to you, you can reward yourself like, okay, I can do that. Okay. If it is not healthier to you, you are not, it is going to be like penalize you. Okay, it will be like maybe causing some of the disease or something like that one. So it is going to be give you a penalty. So that kind of thing is going to be do through the agent. Okay, so this is where in the reinforcement learning comes into picture, where you for the right thing you are going to reward the point, and for the wrong thing you are going to penalize the point. And based on that you are going to learn the new things. So that is the reinforcement learning. Okay. Okay. So just I want to clear some of the basic. So I think that point I already covered. So quickly moving to the next point, that is some of the examples of the AML which you daily see into day-to-day life. Okay. So first of the example which I recognize is the travel and navigation. So let us say that whenever you want, let us say you daily goes to the college, okay, and let us say that you said check the Google map and you put the location like from the home you are going to the Pissoy. So maybe first day you can check that there will be like you will require 30 minutes to reach the college. Second day maybe require 25 minutes to reach the college. How these things are going to be there? Are you let us say that in the first day it is a 30 minutes showing by the Google Map. Is it the same will show on the second day? Have anyone observed this change? Anyone observe this change? Or anyone observe the same path only? वापरलं ना गुगल मॅप सगळ्यांनी?
Student, unmute yourself and speak out.
Okay, so whenever you require, like when you start the navigation, generally the first time which is coming like shown that it will be required this much minutes to reach your location. That depends on what the map is automatically going to detect at what time you are going to travel. Maybe let us say that you are traveling in the morning, and it might show that you require the lesser time, early morning, let us say. If you travel in the afternoon, then it will show more that it will be less time it will be required than the morning session. And if you're traveling in the evening, let us say around the 6 p.m., then it is going to show that you will be requiring the more time than the whatever you are traveling in the previous day. So based on your history of the travel, based on the traffic, based on the time duration, that model which is inside the Google Map, it is going to detect that this much time is going to be required for your location. Okay. Also, if you observe that, it is also going to show you if there is something construction or something repairing work is happening on the road, that is also shown on the map. Okay, and it also suggesting you based on that one, it is also going to suggest one of the optimized route, right? So this is one of the example I think everyone has gone through where the AIML is used, right? The second example is social media feeds. Let us say that I sent request to one of the student from the PCC. I will directly get the some of the suggestion in the feed, okay, you can also connect with this. You can connect also with this. You can also find it on the LinkedIn. Okay. Suppose I send request to Patil sir, then I will definitely get for suggestion for the Pimpalkar madam as well. So that the automatically detection recommendation is happening on the social media, right? Also, let us say that you search some product on Amazon, right? Maybe let us say that you search for the mixer. Automatically, whenever you start your browser, lot of mixer images are going to pop up. Even not on the Amazon, but on the browser. So what is that? All these are the recommendations. Okay, at the back end, whatever your history, how you behave, that pattern is recognized. That data is recorded, and based on that, the recommendation is happening. Right. So this is how actually done in this case. One of the example is that Netflix. Netflix is using AML in a good sense. If let us say that you watch some of the movies, he identifies the behavior of ourselves, what kind of movies you like, and accordingly same movies will pop up on the screen. Okay, and that helps the particularly big organization to increase their profits. Right? So this is one of the things. So now next example is a smart home. So smart home, I think the example you can see that Alexa, there is a Siri, there is a like Cortana. These are some of the chatbots or the devices which will actually help us to remind something. So you can set up the reminder, you can turn on the fan, TV automatically with the commanding the Alexa. So here some of the speech recognition happenings, natural language processing happening at the back end. Okay, so this is also one of the example you can see day-to-day life. And the most, I think everyone has smartwatch, right? How many of you have smartwatch? Anyone has smartwatch? Of course, I know everyone has, or most of the people has. कधी ऑब्झर्व केलंय का ऍप ओपन करून काय असतं त्यात? ओके, त्या स्टेप्स वरनं काय सांगतं तुम्हाला ते? Distance walk, right? Barabar. You also see that based on the step, it also did tell us that okay, you walk this 4,000 steps. That's based on the 4,000 steps, this many calories are burnt, right? So this is actually the what the ML application into day-to-day life. Okay, so from the smartwatch, your data goes to the app. Okay, through the Bluetooth, and through the Bluetooth you will get the like, okay, based on the steps, based on the running or any behavior pattern, you will get the right, okay, this many calories burned, your heart rate is this much, which is not good, which is bad, right? This kind of information will happen. Okay, and also there is like sleep patterns are observed, right? Whether you have good sleep, bad sleep, right? Last night, that is also observed, and it will say that you will require that things, you have to do these things, right? So this is a very good example where you can see the machine learning is quite used in the good sense, and which is I think in the future area also it is like in the health management field, which I'm going to come back to this example, but in the health management this actually a very good thing to be coming into picture. Next thing is the chatbots. I think chatbots, most of the students are going to be used in the customer service, right? So if you go to any application, initially you are going to communicate with the chatbot, not directly with the human or the any backend person. You are not going to comment directly. Your basic general queries will be solved with the chatbots only. And whenever you want more support, then only the things are diverted to the customer representative. Okay, so this is one of the example. I think this is very close to everyone. So whenever you open the Gmail, you automatically find that there are some spam mail, some of the social media mails, there are some of the marketing mails. You can find these categories, right? So this category is automatically made based on the like what is the content of the mail, what is written in the mail. So this is analyzed, and that mail directly jump into that particular category. So this will be helpful to identify what are the spam mails, like what are the fraud mails. So this is very important. And also while writing any mail, you will find out that automatically something detection or correction is going to be there, right? So this is what a natural language processing. So this is one of the example which we can see. Okay, so any example you can see. So I recognize this much, but anything you want to share, like, okay, I have observed this one, this is also based on the machine learning. Anything? याच्या व्यतिरिक्त काही तुम्हाला आठवतंय का, कुठं ऑब्झर्व केलंय का? Anybody has given some online examination, not the university one, but for some of the placement or some of the internship, where you want to make a camera on and there are some like behavior is detected automatically. And based on that, if behavior is not appropriate, then you are like, you will be blocked for the exam. Yeah, so proctoring examing is one of the example where you can see that the AIML is used. So you don't need to go to the like exam room for the exam, right? So it is also, I think most of the university also implementing that, like Amity University is implementing like a proper way, not SPPU. Okay. So now I want to explain one of the project to you, that is, which is I think ma'am mentioned while introduction of me, that is Apple Fruit project. In this one, like this is the project from the agriculture area where like you want to detect apples automatically, you want to track the apples, you want to count the apples from the farms, and you have to give that particular optimized path to Robotica. So as you can see on the screen, like some of the apples image are there, and basically you can see that how the green boxes are drawn around the apples. Okay, so this like some of the inputs images are given to the model. So this is the problem of the object detection, and this is like I think all of you learn like convolutional neural network, right? Anyone aware of convolutional neural network? CNN?
Sir, it is yet to cover.
It to cover, okay, ma'am. I don't know.
Within 2 lectures, we will cover that. It is the last part of this.
Okay. ANN is covered, right? Artificial neural network or not?
Yes.
Okay.
NN is covered.
Okay. Just to give a broad perspective is that in the artificial neural network, we give some of the data, which is like going to be trained some of the layers, and we'll get the output, whether it is a regression model, whether it is a classification model. Now, what is a convolutional neural network? In the convolutional neural network, we are going to give images as the input data, and based on that, certain features, it is going to be determined what kind of image it is. Okay. So here, this is a problem where it is going to be determined what are the apples are there. Okay, if there is other food that is not detected, okay, and based on that one, it is going to be give us like this kind of outcome, right? So it is going to be counting. You can see the numbers on the screen. So this is going to give us the counting, like this many apples are present particularly in the farm. Okay, so this is one of the things which you can see. And what is this application is used? So on this particular screen, you can see that some of the red lines are drawn. So what is that one? So based on this one, let us say that this is the first image. Okay, in the first image, you can see that there are 6 apples are there. Okay, but when I think like in the way that I want to give like how my robotic arm, let us say that this is a robotic arm which is operated by some of the robot. Like how this robotic arm going to move to pluck all the apples. Right? So first, let us say that it will start from this particular position. So it is going to pluck this first apple. Okay, once this is plucked, it will go to this one. Then it will go to this one. Then it will go to this one. Then it is going to be this one. And accordingly, it is going to pluck all the 6 apples. So it will give the path. Okay, it is not like it is going to plug this one, then it is going to this one. So this is not like it will take more time. So we have to optimize the path. So same thing you can see here also. So same thing, you can see that here, from here, this particular point, it is going to start it, and it's going to create its optimized path, and at the end, it is going to plug all the apples. So this is the particularly applications where you can implement into your agriculture domain. Okay, and just a minute. Okay, let me know if video is visible to everyone. Is this video visible to everyone?
Yes, sir.
Okay, so you can see that there are three paths are there. So this particular design is made that whenever we have three kind of robotic arm. So let us say that the bottom robotic arm will work in this area, the next middle one will work in this area, and the top one will work in this area. So once this is apples are detected for all these three robotic arms, so this is created by top robotic arm, this path is created for the middle robotic arm, and this will be created for the bottom robotic arm. Okay, so this is how, once this particular plucking is completed, then it is going to be like, okay, all the apples are plucked, and then next detection will be going to be happen. So this is the one of the example, and this is how it is going to be. So you can see this is actually how it is. So this is the video from the YouTube I have taken. So this is how it is going to be detect the apple. It is going to plug the apple, and automatically it is going to be like create optimized path, and it is going to be harvest the apple. Okay, so this is one of the example you can identify in the agriculture area, which you can think of like in your projects or something like that one. So this is how we can implement AML to advance our agriculture. Okay, so any questions on this one? Any question?
No, sir.
Are you trying to relate anything?
Yes, sir.
Okay. Okay. Now I'm going to share one of the link with you guys.
Sir, I have one question here.
Mm-hmm.
I think we can use genetic algorithm also for this now, path optimization.
Yeah, there are like multiple objective of this problem. First is that you have to identify the apples. So where you can use the machine learning algorithm for that, the convolutional neural network algorithm here. Once the detection part is completed, then you have to create the path for the robotic arm to follow. There you can use a genetic algorithm or any algorithm to optimize the thing. Right? So this can be possible. So here, like it is used like the nearest to pluck one. So once the apple is plucked, it will going to identify which is the nearest apple. So that simple logic is here.
Okay,
Yeah. Okay.
thanks.
Yeah. Welcome. Okay. Okay. Should we move ahead? Anyone has any questions? Okay, then I think I shared one link with Patel sir. Sir, can you share the link with students? So I will give you.
Sir.
Yeah, I will give you 2 minutes to everyone and watch the video completely, and then I can come back and I can ask some of the questions. So I'm expecting the answer at this point.
sure to actually control and manage these.
So we're trying to use machine learning to respond to those diseases.
And TensorFlow is the best foundation for our strategy. The app that we designed can diagnose multiple diseases. It's called Neural. It's what you make your light. The light that farmers can use to see their problems and find solutions. You wave your phone over the specific leaf, look at it, and if it has a symptom, a box will pop up saying you have this problem. When you get a diagnosis, you have an option. You can get advice and learn about the best practices.
The object detection that we use in TensorFlow relies on quantitative images.
We've collected over 5,000 high-quality images of different subspecies for this project. We use a single-shot detector model on a mobile network. It's able to make predictions in less than 1 second.
Instead of having to implement thousands of lines of code, TensorFlow provides a library of functions that allow us to build architectures in much less time.
You need something that can be deployed on a phone without any connection. TensorFlow is able to shrink neural networks to be able to fit on your mobile phone.
The human input is absolutely critical. We're really building something that fits your experience and makes you better at your job.
So with AI tools and machine learning, you can improve the yields, you can protect your crops, and you can have a much more reliable source of food.
AI offers possibility to fundamentally transform the life of hundreds of millions of farms around the world.
You can see a product that can actually make someone's life better. This is kind of revolutionary.
Okay, so I hope everyone has watched the video. Let me know. Anyone require more time? Okay, so what you understood from the video? My first question, like, you don't know, has watched the video or still require some time? Please unmute. So I'd like to hear.
Yes, sir. The team has developed a model from the data set, like the DCs. They have first captured it and then after giving the input and training the data, the farmers are using it so that they can detect early stage that is there any disease on the leaf or not.
Very good, very good. Yes. Yeah. So here you can see that that earlier the problem in the Africa is that basically there is mostly dependent on the agriculture, right? And if some disease comes, like, then the poverty and these problems will come, right? So to solve this one, there is one approach called as a TensorFlow, which is used to identify the disease which is occurring on the plant, so that some additional care will be taken and that can be avoided, and so the production will be increase of the crops. So that is the thing. So my next question is that while seeing the video, some methodology is like told, right? Like how the things are implemented. So can anyone elaborate what is the methodology from this video? Yes, anyone? What is the approach? Like, what is the methodology you can see, like, from the starting of the video to solve the problem? What are the steps are followed? If you see or observe the video again, and you can see that there are some images are recorded from the plant, some of the healthier one, or some of the images which has this particularly yellow pattern or the diseases that is first recognized. Okay, then based on that images, it is like model is created which will identify what is a good and what is a bad images, or which is the images which tells that which is a disease one, okay, which has the disease problem, okay. And at the end, that particular whole model is deployed on the mobile through some of the app, and once that is deployed, you can use simple mobile to check the leaves whether that disease whether that particular leaf has any kind of disease on the plant or not. That is simple methodology is developed, and to develop all this one, TensorFlow library is used. So what is a TensorFlow basically? So while studying the machine learning approach, you, I think, come across the scikit-learn. Okay, so whenever you want to develop the regression model, you use, I think, scikit-learn, sklearn basically library. Right. So similar to sklearn, there is another library which is used in the deep learning, that is the TensorFlow. Okay, so which is mostly used in the particular problem like CNN, ANN, deep learning problem. So TensorFlow platform is very useful. Okay, so just to the purpose of this video is that you should understand the basic philosophy of the machine learning and the AI, how we can solve the simple problems. Right. Okay, now going back to the slides again. So now I will discuss what is a generalized approach to solve any machine learning problem, right? So what are the things are required? What are the steps are required to build a machine learning project? So any case, anything you want to solve, let us say, there you need to understand problem very carefully. So problem understanding is very important. You have to identify what are the objectives of the certain things which you want to achieve. What are the basic definition of some of the terms that you need to understand. And most importantly, you should have a domain knowledge. So what is the domain knowledge basically? Let us say that I want to solve some of the problem from the medical industry. Let us say that I want to detect some of the problem. Let us say that based on some of the test data, let us say you go to some of the testing center, you do the blood testing and all that, and based on the blood testing, I want to detect whether you will have the diabetes in next year, 10 years or not, like that one. I want to detect. So for that one, I should have a domain knowledge of some of the medical terminology. Okay, I should know some of the parameters very well. Then I can definitely going to develop a good model for that particularly fit. Another example, you can see that a chemical industry. In the chemical industry, based on some of the things, you want to detect some parameters or like that one. The chemical process you want to analyze. So you should have some of the knowledge of the chemical processes, right? So this is the domain knowledge. At least you should have a basic domain knowledge of some of the fields, right? Then once you understand the problem very carefully, then you can go for the data collection or data gathering approach. So if the data is not available, then you can develop your own data. If the data is available, you can use the ready-made data, right? So you have to develop if you want to use data collection method, then you have to develop your own methods, and methods will be related to your sensory system. Okay, so let us say that you want to develop a model to identify, let us say, gearbox failure, right? How the gearbox failures are going to be happening. So what you are going to do, we are going to put some of the sensors, which is going to temperature of the gearbox, which can be detecting the level of the oil of the gearbox. So this kind of things are going to be detected through the sound of the sensor. You are going to record, okay, this kind of data. And some of the failures, let us say, occur in during that one. So at which parameter this particular failure occurs, that you are also going to note it down. Okay. And this particular data you can store on the cloud. So what is the cloud basically? So there are you heard about the AWS, you heard about the Azure. Okay, these are all the cloud platforms where you can store the data. Okay, so that data you can use for the building of the model. Okay, so once the data is available, what you can do, you cannot use directly that data. You have to clean the data. So data pre-processing will come into the picture. You have to identify whether the data has some imbalanced things, whether data is missing, whether there is a requirement of the feature engineering kind of thing, whether you want to transform the data, that basic things are required, right? So basically exploratory data analysis is going to be done where you are going to understand whether there is an outlier or not. And based on that, you are going to clean the data. Okay. Then you are going to split the data into train and test. Okay, so that is a very simple step. So you just have that particularly training data set and test data set from your original data so that you can train your model. So anyone knows what is the proportion of the splitting of the data? How you split the data, in which proportion, 50%, or what is the range of splitting? Whether you require more data in training or less data in the test or vice versa. This is a logical question.
Yes, anybody? This is very simple question.
Please ask question because this is not the exam. If you clear your doubts, so it will be helpful in your like career or future perspective. So generally we are prefer to have more data in trading. Logically, of course, it is required. So generally we have 80-20 split or 70-30 split according to data size. Okay. So once we split the data, we have to build the model. Now, as I told you, like first, I think gearbox example, like fault detection. What kind of fault is going to be there? So is it a regression problem or a classification problem? काय प्रॉब्लेम हा रिग्रेशनचा प्रॉब्लेम आहे की क्लासिफिकेशनचा प्रॉब्लेम आहे? It is a problem of the classification. Okay, so we have to select the classification model. If this is the only case of the classification, for the regression you have to check for the regression models. The appropriate model you have to check. You have to test multiple models like maybe the SVM, neural network, anything you want to test first. And once you've done the model building, you have to check the performance of the model, like whether my support vector machine gives me better performance, whether my neural network gives a better performance, or KNN will give a better performance. So accordingly, you have to select which model is giving the better performance, and later you have to tune the hyperparameter. Okay. So hyperparameter tuning is the concept which is very important, where actually you are going to train or tune the internal parameter, right? Okay. If the decision tree is there, like how many trees are required? Okay. What is the concept of the entropy? What is the parameter for the entropy is required? So that thing you have to manage through the hyperparameter tuning, right? So there are like automated tuning option also comes, like there are like grid search is there and many more like that one. So that thing you have to do. Once you select the model, once you analyze the performance, everything is done, then again you have to build the complete model. Okay. So most of the people will stop at this only stage, because here at this stage, at this model is built only on the training data set. Okay. And we also have the test. So what we'll do at this particular rebuilding, we combine train and test data. Once the finalization of the model and the hyperparameters, we are going to create the complete model. Right. So this is the complete model, and this is going to be, we are going to deploy at the output stage. So this deployment will happen through some of the web browser or some of the app we can create, which can be used by the customer or the user, end user. Okay. So this is how the complete the structure of any machine learning problem or the steps are required to solve, right? So here at the latter stage also, so if you gather more data, again you can create, once the more data is available, so you have to create your maintenance strategy. So you have to again rebuild the model. So your model is going to be rebuilt again. So this is similar to you can see that there are certain updates comes, right? Whenever you want to OS or something like that one, there are certain updates in the app as well comes. So you have to update the model again. So this is whole workflow you can see for the machine learning problem to solve. So any doubt in this one? Any question? Okay, very good. So basically, if you see that the sensory system is required when you want to collect the data, so here your mechatronics knowledge will comes into the picture. Okay, so now we quickly move towards the applications. So I think we have discussed these applications earlier as well. So there are like multiple applications like automotive area, social media I discussed, data security, finance, gaming, astronomy, healthcare, transport, agriculture, education, e-commerce, entertainment. So all these are some of the application areas where you can see that AI/ML nowadays is used broadly. Okay. Now we'll see step by step some of the application area. So anyone knows this picture? Let us discuss application in where you can see human-machine interaction. Anyone know this picture? Anyone come across some of the news?
Yes, sir, yes.
Yes, what is this?
Sir, she is Sophia robot, sir.
Very good, very good. What is your name?
Science, sir.
Very good, very good. So this is Sophia. And what is the specialty of this robot is that this is the first robot which got citizenship, official citizenship from one of the country she got. So this kind of robots is called as a humanoid robots. Okay, and this particularly works on computer based on the basically AI and the machine learning at the back end. So the country which has given the citizenship is the, anyone knows the name?
Saudi.
Yeah.
Saudi Arabia, sir.
Yeah, very good. So Saudi Arabia has given the citizenship to Sophia. So it is like that. It is a one human in the Saudi Arabia. So this is the first robot, and there are a lot of controversy also, but we don't go on that one. But it is developed by the Hong Kong-based company called as Hanson Robotics. This particular robot learns by itself based on some of the experiences, how you behave with her. So this is how it is actually now comes into the picture. Now there are like nowadays I told while discussing initial slide, there are smart home concept comes into the picture. So Amazon Echo Bot is there, Alexa is there, right? Now you can see that these particular bots are used to assist, like not only like for the comfort or something like that one, but if you see the elder ones, where some of the reminders for the, let us say, for the medicines, some of the things which we don't keep in the mind that can be given by this particular bots. Okay, so this kind of devices always going to be assist people for the better like life or something like that. Okay, so it is helpful for the setting the reminder. It is going to be helpful for identify the mood. Accordingly, it is going to be play some of the songs to relax your moods. So this is how actually automatically based on your interaction with that particular device, it is going to happen, right? So this is one of the things now comes into the picture. One more example I want to show is the robots now used in the industry. So now this is the picture from the India only. So this is a picture from the Bangalore where robots are used for the serving the food to the customer. Now here again the orders are placed, all these are based on the AI, right? So this is also one of the example you can see where you can see that humans are interacting with the machine, and basically machines are the robot or any kind of device. Okay. So anyone resembles, anyone identify, or anyone remembers anything else from that one? Any example you can see where human and machine interaction happens? And at the back, it will be some kind of AI and the ML is there. Okay. next slide. So here I will discuss morely the applications from the mechanical perspective. Okay. So in the mechanical industry, you can see that the screens, you can see that there are a lot of large screens is there. So this is basically a SCADA and HMI system. Okay. Here the process monitors basically happens. Okay. So you can see that there are like, these are the process, this is the, from this one, some of the sensors are placed. Okay. From that sensor, we will get the data for the operator to identify like how the process is running, if any parameter is going out of the limit, and if some parameter is going to out of the limit, what will be the things needs to be done. So that particular process will be taken care by the AIML. Let us say that some of the warning messages, you can hear like there are some of the alarms in the industry are like at a certain point of time it is going to blow. Let us say that at a particular this point, maybe let us say that this particular process it's let us say block. Okay, so automatically pressure is going to be changed, and this particularly shown on the screen like, okay, this pressure is going to be changed, and this happened at this location, and accordingly this maybe the things can happen, so you have to stop the machine immediately, or you have to, or even if human is not there, it will do by its own. So that thing kind of thing can you see in the industry as well. Okay. Now we see some of the examples in the predictive maintenance. Okay. So now as we are moving with the industry 4.0, so a lot of data is now available when there is evolution of electric vehicles, battery-driven vehicles, and all these things. So what is happening nowadays is that once the sensory system is coming into the picture. So in the sensory, I think you are aware of engine control unit, right? You can aware of CAN protocols. So all these devices are mounted on the vehicles from where they actually a lot of sensors are placed. Okay, sensors are placed at various locations of the vehicle, which will be used to detect the, let us say that maybe one of the sensor is going to be recording the fuel consumption of the vehicle. Okay, so that data is going to be sent to some of the model. Okay, now let us say that this vehicle is running on this road, and this is going to be like, let us say that it is consuming, let us say 5 milliliter per second, something like that. Okay, that information is sent to the particularly the model. And the next second, maybe like it goes from 5 to 10 milliliter per second. Then it is like significant increase. Okay, so model will detect, okay, the 10 milliliter, that means something is going to be wrong at the back end. So it can send the signal to the operator. Okay, so operator or the driver that, okay, you have to do the maintenance of the vehicle. Maybe there is a filters are blocked or something like that one. So you have to do your predictive maintenance, that kind of thing. So this happening nowadays. So this is online monitoring comes into the picture. Okay. Also, you can see the fault detection. So whenever, let us say in this particular example, here it can tell us that this particular bearing, this is the data for the bearing, and this bearing can fail after the 3 days or within the 3 days. So either you can replace the bearing to save the machine, or take some corrective action so that bearing can won't be failed. So that will be depending on this particularly distance calculation, and this particularly this is the actually the forecasting data. Okay, so it is this is particular problem is called as the forecasting. So what is the forecasting? Basically, it is going to be here in the supervised learning case we define like where we have the X, where we have the Y. So here we have the features, and here we have the output. Okay, but in the forecasting we have T only. the time. Okay, so based on the time, let us say at this particular time, let us say today, maybe the distance is like 2 mm. Tomorrow, sorry, I will write as a 10 days back or something like that. On the 9th day, maybe it is coming as a 2.001. Likewise, okay, and you determine at the today it is like this one. So accurately you can predict what will be the distance of the particularly bearing layers that will be after 3 days. Okay, and based on that you can decide whether this bearing is going to be fail or not. So this kind of thing you can predict with the help of machine learning. Okay, then there is one problem you can solve, that is the anomaly detection. Anomaly detection means that if some data is recording with respect to time or the frequency, that any magnitude will go at particular higher, okay, than the requirement. So if you see at this particular region, it is go like this way, but at this particular it is going to be very high. So at this point, you can give the direct message to the operator that this thing happened and you have to check the system. So that thing you can assist with the help of AI. Okay. So this is one of the examples. So any doubts till now? Are you trying to relate or not? Okay, so I assume that everyone understood. So these are one of the examples where the things can be used in the automatic prediction of the failures. So one of the next applications is fault detection. So now, as I said, I think shown in the example of the car, we have the sensory system, right? We have the sensors which can record the data, okay, and that data we can use to train the model. Okay, we can make the model from the data, and from that data, if you train the model for the failures, okay, so last case, let us say that if the vehicle has a failure when this particular fuel consumption increased by this level, if the temperature of some part is going that way, so this failure is occurred. Okay. So that particular information, if you have previously, on this one you can create the model. Okay. Now in the next case, once you have the model, okay, and we have this particularly now the model again having some sensory data. Now this is a present data. Okay, so it will tell that this is a fuel consumption of the vehicle, this is the temperature of, let us say, for some of the part, and based on that whether there is going to be failure or not. Okay, if these things are in control, then there is no failure, that particular going to be shown to the driver. If there is something then wrong with this fuel consumption or anything, any other parameter, then the message will go to the driver that okay, this failure is going to be happen. So automatic fault detection will happen in this case, and based on that we can create a model and which will be going to predict the certain faults which are going to be prevent the cost of inventory, cost of failure. So this will be very important. Okay, so this is an example of the, I think, windmill turbine, where this particular model is built and which is going to automatically detect the, based on the certain features, it is going to be build the model and this is going to predict the some of the failures. Okay, so any doubt in this slide? Sorry, can you repeat? I'm not able to hear. Hello? Hello? Okay. Okay. If if there is no doubt, I can move to the next slide. Okay, so this is another problem. You can see that. So in some of the chemical industry, petrochemical industry, it is very difficult for the maintenance. Okay, and some of the locations where, let us say, that you cannot reach with the piping, basically it is very difficult to reach by some of the maintenance guys there. So by using the camera techniques and all these things, you can identify where this corrosion can be happen. So, okay, you can detect automatically corrosion, and based on that you can check, okay, the corrosion is happened at this location, so you need to change these particular parts. So that is also important to identify whether it's the corrosion, cast, weld quality. So this particularly comes into your quality, automatic quality identification without the human intervention. So that is also done by the particularly with the help of AIML. Okay. Now next we'll go towards the health management. We'll see some of the applications from the health management. Now before going to this one, anyone knows or anyone come across any application where you can observe the AIML in the health domain? I think I already told one application to you guys, that is a smartwatch. Okay, so AIML is very useful in health management system, where we can use these particular applications in building new drugs, detecting new diseases based on some of the patterns, or the forecasting new demands. So that can be done in the health management. So one of the application is a smartwatch. Okay, so in the smartwatch you can see that your heartbeats are recorded and that are sent on the apps. Okay, so that data once goes to the app, then this data is stored on the cloud, and based on that cloud, if let us say that any person has heartbeats more than the normal one, that can be like automate the process that in the medical system, that some doctor will call him that to assist that particular person. Okay, that you have this one, so you have to check up on this thing. So that can be thing we can automate. Also in the elder persons where there is no one to look after, then we can use this particularly automation system. We can use the sensors where the basically heart rate, any parameters can be detected, and that will be automatically monitored with the help of doctors. Okay, so this can be done with and this is, I think, very useful nowadays. I think most of the guys are using. So this is already done. So this is there. Also this application, you can see that useful while driving. Okay, so you can observe that many drivers has heart attack while driving when they drive generally in the night. So this can be this particular pattern can be automated to detect and can be prevent the loss to other people as well. So that is automated data and can be monitored very well. Then you can come across the robotic surgery. Now I don't say that this completely use the AIML, but it is going to assist the doctors while doing some of the critical operations, by using some of the cameras, some of the decisions which can be made by the robots. That is useful for the doctors because this is very critical job, and this is one of the area where the AIML can be used in the health management. Also, you can see in the detection of the cancer. So based on some of the patterns of the cells, you can create the classification models by observing the cell pattern, how cells are modified, and it is going to be detect the cancer in the early stage so that you can save the lives of the people, many lives of the people. So that is one of the areas where you can see the AIML can use broadly. Now, I think this is one of the recent example where I think you can heard the word like, okay, fourth wave is coming, third wave is coming. So how these things are predicted based on the data. Okay, so this forecasting is predicted, and I think that help us. I think in the last wave, this is help us while fighting the COVID. So earlier that we predicted that third wave is, I think, coming. So people are aware that and some of the restrictions are made, and in that particular region, it is, I think, less impacted. So deaths are very less. So this particular knowledge we can use from the previous data, and definitely that can be used to make a better life. So these are some of the examples you can see from the healthcare domain. Okay, so I think I covered some of the areas from the application point of view. So if you have any questions from us, you can ask them. Any question or anything you want to suggest, like, okay, this can be used.
Students, if you have any question, sir is there, and this is the rare opportunity we get to interact with sir, who is especially working in the field of artificial intelligence and machine learning. So if you have any general question or career opportunities or any question related to content, you have to unmute yourself and ask the question, or you can put your question in the chat box. We can take this up.
Questions are most welcome, because I think most of the people have like problem like with the mechanical field, like, okay, I'm from the mechanical fields, so maybe this is not our interest area. But like nowadays, the mechanical are the people only can develop good models because they have the good knowledge of the hardware, the mechanical. So the example which I already shown you, that the Apple project, so where the robotics is used. So or to develop the robotics and all these things, you need a knowledge of the mechanical and the sensory system. So yeah, so for the mechanical is actually a very good area for by career perspective. So do not think like this is a programming only. Yeah, programming is required, but I think programming is not tough. You can learn basic programming, and Python is very easy. Any use case you want to discuss, like, okay, I'm thinking this particular problem, how we can solve, we can discuss, definitely.
Hello, sir.
Yes.
Sir, I have one question on traffic jam, sir. One German person take his family's mobile up to 100 and walk on road. So the traffic jam, Google Maps show there is a traffic, but there is no single car on a road. So how can AIML that counter this problem, sir?
Can you repeat the question? Actually, there is echo. Sorry. Can you repeat the question?
Hello, sir.
Uh-huh.
One German person take his family's phones and walk on road, sir. There is he walk on road and there is no single car on road. But still Google Maps show there is a traffic on that road. So how that problem is counter with the help of AIML?
So this is the problem with the model only, no? So the model is giving you a wrong response. So you have to build the model properly in that case, to assist the properly. If there is no car, that means that it is detecting wrongly that the behavior of the traffic. So model is wrong. So you need to create the model correct. Then only this is going to assist in a proper way. Are you clear? Or
Sir, so how can do that create a model, sir? That is a Google Maps problem, sir.
yeah, the Google Map is basically working on some of the model, right?
That took location of mobile, sir.
Sorry. What do you say?
Google Map took mobile location and predict where there is traffic on a road or not.
Right. So basically, what will be the cases in that case is that Google Map will identify the past data or past traffic performance. Okay. So based on that, it can predict the things. But again, there is you came to know that, okay, this is predicting wrong. That means that it has some problem with the model. So again, you can train your model on the existing data. So you have to update your model basically, the which Google Map is using. And then only it is going to be make your corrective decision. Getting?
Yes, sir. Okay, sir. Okay.
I'm telling is that model, model is wrong basically. So you need to correct the model.
Yes, sir. But there is a Google Map not use a surveillance camera, sir. Now.
Mm-hmm. Yeah, you don't.
On traffic road.
There are some satellite signals are used generally. Through the satellite, it identifies the patterns on the road, and based on that, we'll get the things.
Yes, sir. Okay, sir. Got it clear, sir.
Yeah, thank you. Anyone else? Hello? Yes?
Students, any other question?
Okay.
Yeah, it seems that there is no any other question. So thank you very much, sir, for your valuable time and providing more insights into artificial intelligence and machine learning, especially from mechanical perspective. Many times as a student, generally students think that mechanical engineering ML has nothing to do with. But from your session, we came to know that as a mechanical engineer, we can do a lot of things and perform better than a typical computer engineer, because we have better understanding of hardware systems, especially